Hello, this is Zachary Chenoweth, and this is my presentation of Lab 2, Task 3, Wall Following Through a Maze. For this task, we have to have our epoch robot traverse through a maze while wall following, making only left and right turns depending on the controller we are using. This controller here is our left turn controller. So we have our initialization for the robot and initializes the distance sensors, cameras, motors, etc. Here we have our constants where we set our min and max velocities in inches per second, our proportional gains for the front distance sensor and the left and right distance sensors, our desired distance from the walls, and the amount of time we want our program to run for. Here we have our F saturation function, which is used in the PID calculations. And basically all this function does is it caps the calculated velocity to the minimum and maximum velocities that we placed here. So if the calculated velocity is greater than or less than the min and max velocity, it'll adjust it. Here we have our turn left function. So basically all this does is that if the robot comes up to a wall and it can make a left turn, meaning there's no wall on its left side, then it will turn 90 degrees to the left. This function called turnaround is for when the robot comes into contact with a wall on both the front and the left side, so meaning a left turn is not possible. It will turn 180 degrees and go back the way it came. The forward velocity function uses PID to calculate the velocity that we want to set the wheels to. So basically it takes the current distance, calculates an error based on the desired distance we want from the wall, which is 7 inches. And then we take this error and multiply it by a KP value, which is our proportional gain. And then we saturate the calculated value using our F saturation function. We then convert it into radians per second because this calculation is in inches per second. And then we call our left and right wheels so that way we can adjust the velocities depending on the sidewalls. The left wheel function here is similar to the forward velocity, except with some slight differences. We calculate an error using the opposite distance sensor. So if we're using the left wheel, we want to take the reading from the right distance sensor. And if we're on the right wheel, we want to take the distance sensor on the left. After calculating the error, we adjust the velocity accordingly. If the error is negative, then we don't want to change the velocity and we set it to what we calculated. Otherwise, if it's positive, then we want to adjust it because that means that we are too close or too far away from one wall. The right wheel does the exact same thing as the left wheel, except on using the left distance sensor and adjusts the right wheel's velocity. Here in our main loop, we have our time passed since the simulation started, our 3 distance sensor readings printed out in 4 decimal precision. And then we have our if statement that says if the time passed is less than the 90 seconds that we set previously, then we want to go ahead and move the robot. If the front distance sensor is reading greater than 7 inches, then we want to go ahead and move forward. Else, if we're up against the wall, meaning the front distance sensor is reading 7 inches and our left distance sensor is reading a wall on the left side, so it's stuck in a corner like right here, then we want to turn 180 degrees, so we call the turnaround function, else we want to turn left. If the time passed is equal to 90 seconds, then we're going to go ahead and stop the robot and break from the loop, ending the program. Now let's go ahead and see it run. As you can see, the robot starts out forward and it's gonna kind of zigzag in between these walls because it's adjusting its distance between the walls. So if it's following one wall, it wants to be 7 inches away from that wall. As you can see, it couldn't make a left turn, so it decided to turn 180 degrees around. And then it's going to continue back the way it came, again adjusting for the sidewalls. Once it hits this part right here, it can make a left turn, so it's going to go ahead and turn 90 degrees to the left, and then again continuing forward. In this box here, you can see the camera that the robot is using, so you can see what the robot is seeing. Again, the robot turns left and is going to go ahead down this corridor. Now, the issue with being able to only make left turns or right turns, depending on the controller, is that in certain orientations of the maze, you'll get stuck in an infinite loop because it will never be able to make a left and right turn. So as you can see now, the robot is going to be stuck in this part of the maze because every time it comes up against the wall, it has a wall on its left-hand side. So it will not be able to go ahead and make make a turn. And once the 90 seconds have passed, the robot's going to stop where it's at, ending the program. All right, let's go ahead and see the right turns controller. So in the right turn controller is basically the exact same as the left turns, except instead of left turns, we're doing right turns. So we have our initializations, our constant variables, our F saturation function, our function to turn right. So this is different from the other one in the sense that it turns to the right instead of the left. So it turns 90 degrees to the right. We have our turnaround function, which is the same as from the previous controller. And then we have our forward velocity, left wheel, and right wheel, which is exactly the same as the left turns controller. And this calculates the velocity that we want our robot to go. Here we have our main while loop where we have our distance sensor reading and our time passed variable. And then we have our if statement that says if the time passed is less than the 90 seconds, then we want to go ahead and move forward. If the if the front distance sensor is reading greater than 7, else we're going to go ahead and look and see if there is a wall on the right-hand side. If there is a wall on the right, it will go ahead and turn around. Otherwise, it will turn right. And then it's going to go ahead and stop the robot if the time passed is equal to 90 seconds, and then break from the loop, ending the program. Let's go ahead and see this run. So as you can see, just like the left turns, it's going to go ahead and start off and it's going to kind of zigzag through here because it's adjusting based on these walls. Once it gets here, it can make a right-hand turn, so it's going to go ahead and turn right and continue forward. Again, it can make a right-hand turn, so it's going to turn. And turns once again. And now just like the left-hand controller, because we're only making right turns, it's going to go ahead and get stuck in an infinite loop right here, because once it comes up onto this wall, it sees that it has a wall on the right, so it can't make a right turn and does a 180-degree turn, and it gets stuck right here until the simulation reaches 90 seconds, and then the program forces it to stop. That is Lab 2, Task 3, Wall Following in a Maze. Once again, my name is Zachary Chenoweth, and I hope you have a wonderful rest of your day.